So today's session will discuss about Docker. So what is the Docker is in the DevOps today, market is with the Docker and the Kubernetes. Lot of market is there. To understand the Kubernetes also is Docker is is the basic thing. Means we require the prerequisite. Directly we don't use the Docker, but to understand Kubernetes, OpenShift. So these kind of tools to understand we required Docker. Okay, so now what is the containerization? All those we'll discuss. So before Docker, like to deploy the applications, okay, we require the virtual missions, but today we are not going to use the virtual missions. We are going to deploy on the containers we are going to deploy. So the containerization is a new thing in the IT deployment and mostly the microservice applications we are going to deploy. Okay, so previously people used to tell like developers also in the dev environment that is working, but in the QA environment that is not working or in the production that is not working. But containerization is going to resolve that kind of problem. Okay, so Docker is going to package our applications and those are running as a microservices and all the application code dependencies, all we are packing into a single unit or container, and that's easy to move. Okay, so easy to develop, easy to deploy and run, scale, scale up and scale down also is very easy to perform. So with all these factors, nowadays, like most of the applications are moving into microservice kind of things. So by default, Docker is going to solve the packaging of our applications and all their dependencies into a container. Okay, so that's is very simple to run. That is very simple to run. So that is the reason the containers are getting popular day by day because those are very flexible, lightweight, and even we can interchange, portable, scalable, and stackable kind of things. So these are the advantages of containers. Okay, so why the containers are getting more popular is so that it's easy to deploy and even very flexible also. The complex microservices also easily can be containerized and very lightweight, and even we can interchangeable also updates, all those also on the fly we can perform those. Portable, we can run anywhere. Okay, so compared to virtual missions, these are very lightweight also. So people will ask us one scenario, that is like we have already virtual missions, but why we need to go for containers? So we have already the virtual missions are there, but why we need to go for the containers kind of things? So those also will discuss. Okay, so now here we have two things, image and containers. Before that, so we need to understand mostly containers came with the Linux kind of operating systems. Mostly with the Linux operating systems, we got the containers, but it's not only now Linux, Windows, even Mac also it is supporting. So now in the Linux, we need to understand one concept called as namespace and C groups. Okay, so now we are going to create an isolated environment on the Linux missions. So behind the Docker containers on the Linux, what is the core technology is namespaces and C groups. C group stands for control groups. Okay, so namespaces are going to isolate. Say suppose assume we have a very big floor, but we are going to divide that into rooms or not. We'll have a wall, that wall is dividing between the two rooms. In the same way, we have the Linux server. The namespaces are going to provide isolated environments for each container. That means Linux in the backend, containers are using the namespaces, and each container is just like a room kind of thing. The complete VM is the complete floor kind of thing, and each container will use like that own isolated namespaces, and each namespace will have their own Linux process, and that's like we can have their own host name, network, process, file system, all those is going to be provided. That means the namespace is whenever the namespace is there, that is going to create its own network, its own process ID. It's going to have their own mount file systems. Okay, then user, IP, all these we are getting. Okay, that means on the Linux namespace level, so what is happening with the namespace level? We are getting isolation. We are getting the isolation. Then C groups are the full name is control groups. Okay, so control groups, what it is doing is, say here control groups, how much, say suppose we have for our VM level, I have two CPUs and 4 GB RAM and I have some storage. Then for that namespace, how much CPU, memory and IO for that container, how much can be allocated for each. Say suppose at the VM level also, when you choose the instance type, we are getting one CPU or two CPUs. That is at the VM level we are, but control groups are managing at the container level inside the Linux. For your host, you have given 2 GB RAM and sorry, two CPUs and 4 GB RAM. But that memory and that CPU also is allocating, that CPU and memory also is allocating to containers, and who is going to control that is C groups are going to control that. That kind of resource limits are controlled by C groups. They both are like are creating containerization kind of environment on the Linux missions. Okay, so using this an isolated environment, our container is running. So now here people will ask us, what is the difference between virtualization versus containerization? Okay, so we have the virtual machine. On the virtualization we are getting a container, we are getting in the containerization. Okay, virtualization is providing at the hardware level. We can run multiple operating systems on a single hardware we can run. What is the main challenge is, like it takes lot of hardware and we can run the multiple operating systems, like we can run the multiple operating systems, but the containers are providing at the OS level, isolation is can be provided, and those are very lightweight, easy to scale up, easy to scale down, and easy to increase also. That means I want to create 1,000 replicas, that's very easy to deploy, and we no need of any hypervisor. But to run the virtual missions, we run a lot of hypervisor is required. So now, if you go for a virtual mission and a container, can you tell me which is lightweight? Which is lightweight? Container is lightweight or VM is lightweight?
Container.
Yeah, containers are very lightweight. Okay, so then provisioning is which is fast. Provisioning is fast. Fast startup is possible with VM or container. So VM will take minimum 5 minutes to start up. The complete application, VM, database connections, all that minimum will take 300 seconds. But a container can be started up within a seconds also. And easy to scale up and easy to deploy also containers. Okay, so mostly for the microservices, automation, auto scaling kind of things, containers suit for the real scenarios. Okay, but compared to virtual machines, less security is there. But we need to adopt a lot of security standards, but compared to VMs, less security are there. Okay, so then with the hardware and kernel, weaker isolation. So weaker isolation also, but it's little security wise will have some requirements, and more resource usage is there for VMs. Okay, so that's performance wise also containers are the best one. So with all these, like we have a lot of advantages to use the containers for the real applications in the microservices. Okay, so we have two types of applications. So try to understand monolithic application versus microservices application. So monolithic application and microservice based applications. For the monolithic applications, it's better to go for VM, and for microservices, we are going to use containers. On top of the containers, we want to scale up some thousands of containers, auto scaling, load balancing, all these self provisioning, auto destroy. So these kind of features we required. For that, we required container orchestration kind of tool. Okay, so that kind of container orchestration tool is the Kubernetes is the container orchestration kind of tool. So only we don't run the 10 to 20 containers. We are going to deal some thousands of containers. We are going to deal that kind of orchestration can be done with that kind of container orchestration can be done with okay, Kubernetes kind of tool, or we have Docker Swarm is there. The Docker is normal containerization tool, but Docker Swarm is a orchestration kind of tool. Okay, then on top of this, even we have OpenShift we have. Okay, so OpenShift also is one of the orchestration kind of tool. Orchestration kind of tool we have. Okay, so now the containers in the backend is using Linux namespaces and C groups. On top of that, we are going to run these. Okay, then so we'll discuss what is the Docker is. So what is the Docker is a Docker is a containerization tool. Okay, so the backend so we'll discuss. So Docker is one of the containerization tool. Then not only Docker, we have containerd, we have runc, podman. So these are all the different containerization tools. So among that, Docker is one of the popular container engine. Okay, so but on top of container orchestration, so we have Kubernetes, Docker Swarm, OpenShift kind of tools we have. And if you go to the architecture of the Docker, okay, say in the Docker architecture, okay, say inside the Docker architecture, say we have Docker client, Docker daemon, or Docker engine we have, then Docker registry. Okay, so we have the Docker registry we are going to use. So we have the Docker client, Docker daemon or Docker engine, and Docker registry we have. Okay, so now in the Docker client is a command line kind of tool. Okay, so mostly Docker client that uses with the CLI or REST APIs is going to hit the Docker daemon. Say using the Docker daemon, we are going to run the containers, all those on the Linux or Windows. Then the images, all those we are storing in Docker registry. Okay, so this in our scenario, we have a Docker Hub. So Docker Hub is the registry. We are going to store all the images and we can pull the images from there. Okay, so from that we are going to run. So Docker client is the interface where the users can run the Docker commands. Okay, so those commands will communicate with the Docker daemon using the REST API and communicate over the TCP. Then Like those commands are running, and the heart of the Docker is the Docker daemon. It runs the backend images, pulling the images, containers, network, volumes, all those is going to communicate. Okay, that network drivers, storage drivers, communicating with the other daemons, all those is manages. Then we have the Docker registry. The Docker registry is the place where we are going to keep all the images. From there, we are going to run those. Okay, so then so here we have two more things are there, very important. The Docker images and Docker containers. So what is the difference between Docker images and Docker containers? In the AWS also, we have an AMI. AMI is a pre-configured OS template. So from that, we are going to run it's going to run that like a instance. The running state of the instance is called as an image. The running state of the instance is called as an image. So now here also we have like images and containers. So we have the images. Okay, so now the images are nothing but the Docker images are nothing but it's a blueprint of a blueprint of the OS templates, or maybe like whatever the containers we want to create. So that blueprint is going to be getting. Say those are the templates. Okay, they used to create containers. To create the containers we have. Okay, so then using the Docker file, we can create our own images, or automatically we can get those images even from the Docker registry. We are going to get it. Okay, so from the Docker registry, we are going to download those images. And whenever we run that image, that's going to become a container. Okay, so that means the container is going to be the running state of the image. In the same way, instance has been created from a AMI. And a single AMI, we can have multiple containers, it can be running. That means Ubuntu 24.04, some millions of people have created the instances. In the same way, single image, multiple people can run that containers. So that means a container is a runtime instance of an image. Okay, so that image required when it's want to run as a container, it required memory and CPU, disk IO, storage, all that's required, that uses that host resources. On top of that, it's going to provision the container, and it uses the Linux namespace isolated environment. It is going to run. It is going to run on that in an isolated environment. It is going to run. Okay, so now images is a template kind of thing or executable package that includes like OS, application code, runtime, libraries. Okay, so but it's a file kind of thing, and we can store that in the Docker registry. Okay, so whenever we want, we can download it from the Docker registry. We can download. Okay, so then that container is a running instance of that image. Okay, and in the Linux, those are getting isolated by using the namespaces and C groups. Okay, so then we can start, stop, delete. Okay, so that restart kind of operations also we can perform. Okay, so these all we are going to get it. So now try to understand. So we run the command docker run nginx kind of command. So whenever we run this command, say this is from the CLI to, this would be sending to Docker daemon. Docker daemon will contact Docker registry for the nginx image. That nginx is the image there. Okay, first the Docker daemon will search on the local mission whether that nginx image is existing. If not found locally, then that is going to pull the image from Docker registry is going to pull it. Okay, if not available locally, then it's going to pull, then it's going to create a container and it will start the executing the container also. And for that container, it is setting up the namespaces, C groups, and it's going to give the process also. Based on that, like we'll have every image will have one command, and using that command, container is executing. That container is executing using that command. Okay, so these all the steps are going to happen in the backend. Okay, so whenever we run the any of the command, Docker CLI will send to Docker daemon. Docker daemon will search locally whether that image is existing or not. And if that image is not existing, it's going to pull that image. Okay, then it's going to execute that using the Linux namespaces and the C groups. Okay, so that's we are going to get that. Okay, yeah, any doubts on this? Okay, so on Ubuntu mission, if you want to install Docker, it's very easy. So just a sudo apt update, sudo apt install docker.io. That is the package we have. Then Docker, sorry, systemctl enable Docker. Okay, so these are all the commands. So just type, then type the Docker, write down all commands. Okay, then type Docker info. But as of now, before this, we need to run sudo need to be run. But without running the sudo also, how to discuss? We'll see. Okay, say sudo Docker info will show basic details about the Docker. All those it is going to show for us. Okay, so these all the commands on your Linux mission. I sent in the chat. Everyone copy that. And everyone need to run those commands. And what are the components we have in the Docker architecture? In the Docker architecture, we have Docker CLI, that means Docker client, then Docker daemon or Docker engine, then Docker registry. Then we have the image versus container and virtual machine versus container. So these are all the mandatory questions people will ask us in the interview also. Okay, so those are all the things we need to discuss. Okay, so then, so on this itself, we can run one more command, that is Docker run hello world also. Docker run hello world also. Okay, but as of now, we are giving sudo. Okay, but without giving the sudo also, we can run. So without giving the sudo also, so we can run those. Okay, but for that we need to perform some changes. That we'll discuss. As of now, Docker is required root admin permissions to run those, but we can add a Docker user also to that. Okay, to the Docker group we are going to add. So from that we can give those permissions. Okay, so now here, like what are the things we need to come with this is, so everyone should able to explain Linux namespaces, Linux C groups. Okay, then what is containerization versus virtualization? So what is the difference between containerization and virtualization. So what are the differences between containers and virtual machines? So then the same way we need to discuss VM versus containers also. So what are the differences between VM versus containers also we need to discuss. The VM versus containers. Okay. So then like here we have Docker image versus a container. Docker image versus a container also. Okay. Then like container advantages, disadvantages, virtual machine advantages, disadvantages. So these also, so people will ask us. Then when one more difference, monolithic applications versus microservice applications. Now, like that application may be existing in the last 10 years also, but at that stage, it would be the like a monolithic kind of application. But now the same applications are migrating to microservices. The same applications are migrating to microservices. Okay, so that's we are going to use like a microservice kind of applications we are going to deploy. Okay, so mostly we are going to use microservice kind of applications we are going to use. Okay, so then try to install Docker also. Then once we install the Docker, so what are the components we have is Docker client, then Docker daemon, Docker registry. Okay, so then like here we have image, container, and we need to discuss the networking, how we are getting for the container and storage options also. So what are the storage options we have with the containers? What are the storage options also we have with the containers? All these also. So we need to say suppose by default the data inside the container is not persistent. By default the data inside the container is not persistent. So for this persistence purpose, we are going to use the container storage, and the networking wise also we are going to discuss like a container network also we need to discuss how the networking we are getting, what are the IPs we are getting also we need to discuss. Okay, so on the Ubuntu mission, try to perform these all the things.